sound check. Is this okay?
Yay.
Yeah, if you don't recognize the guy there, he's some relationship to me, but I'm not sure exactly. So I want to take the opportunity today to kind of explain the role Tektronix had in the first really decade of the emergence of Smalltalk and some of the influences it had. And those of you who've been around this area for a long time probably know many people who were involved in this story, and those of you who are newer may have never even heard of Tektronix. So we'll see where this all goes. I wanted to mention down at the bottom there's an URL there, which I don't know if you can read it, but the important part is Wirfs-Brock.com/Allen, that's A-L-L-E-N. If you get that far, you can find the rest of it. This deck is there, but more importantly, I put together a page that has links and commentary to all the sort of primary documents and artifacts that I'm going to be showing here, plus lots and lots of materials that just I don't have in the presentation. So if you want to know lots about the early days of Smalltalk, go to my site. So Tektronix, for those of you who don't know anything about it, was an electronics company that was founded in 1946, and its origins were that its founders really invented the modern oscilloscope. And based on that, Tektronix really grew over the next couple of decades to be one of the largest and most important electronics companies in the world. What the tech scope did is brought in the concept of what's called triggering, so that when a waveform is going by, to detect a particular transition on the waveform and use that to trigger the display. And so you got a stable image that you could use to actually measure electrical signals and stuff, and the behavior of circuits. And before that, it was just this random stuff. You sort of tuned a knob and you tried to get the balance, and it really wasn't very useful. And so oscilloscopes really enabled, are really the debugger, if you will, for discrete electronics from the late 40s up through about 1990. One of the things, and if you haven't actually worked with oscilloscopes, you've probably seen them in the sets of sci-fi movies and stuff. But one of the things on this picture scope here I have in the middle is called a storage scope, and a regular oscilloscope is good for detecting repeating things that occur over and over again, and you trigger, and so you get refresh, and it's just this nice stable on the screen. But some things happen only once, and you want to capture what a waveform looks like as it occurs only once. So Tektronix developed a technology where actually a signal going across a CRT would be captured on the phosphorus of the display, and it would persist there for an extended period of time, hours. And so basically you could just capture an image on the screen. And after a couple decades of that, some engineers at Tech said, hey, if we can draw a line on the screen and it will just stay there, that's a really inexpensive way to do computer graphics. And so in the early 70s, Tektronix developed a line of low-cost computer graphics terminals that were based upon this storage tube technology. Now, at the time this was going on, your typical computer graphics device was probably $50,000 to $200,000, and it had some sort of storage and its own processor doing refresh and just all sorts of complicated stuff. These tech storage, because they could just store the lines on the screen for between $5,000 and $15,000, Tech provided terminals that did real graphics. And so that's why, for that period of time, they really dominated the computer display industry. So, well, as things had to happen, so they had these, we're doing these terminals, and terminals evolved into a desktop computer. The tech developed a machine called the 4051, which was essentially one of these graphics terminals with a processor in it running a BASIC interpreter. And it was arguably the first real desktop graphics personal computer. Introduced in 1975, about the same time IBM introduced a machine coincidentally called the 5100, which also ran BASIC and APL. But I think those machines actually are the contenders to be who was really the first real personal computer. So again, this is a quite successful product line. Thousands of these were sold. A huge business was built up around those. Big area of success for Tektronix. So that's sort of setting the stage for what came next. So in 1980, I and my colleague Paul McCullough was working in the group at Tektronix who was responsible for these desktop graphics machines, and there was a whole big effort to build a next generation that supported multiple languages and stuff. And specifically, Paul and I were working on a Pascal compiler for the not yet quite shipped Motorola 68000 processor. The idea was that the Pascal compiler was going to be used as a systems programming language for various tech products that were going to incorporate the 68000. One of them was this thing here that was trying to look like, again, an instrument, but in fact was another computer that ran BASIC and stuff. Rebecca Wirfs-Brock was leading the development of software of what was actually a very sophisticated file server that was running not on a network like Ethernet, because we didn't have Ethernet then, but was actually connected together with this interfacing technology called GPIB, General Purpose Instrument Bus, which was this big, thick cable and was really designed to interconnect data collection devices, but we used it to attach to a sort of a multi-machine file server. And so that's what we were doing. We were in this group, and Paul and I were in this group that was within the overall group was called GCS, Graphics Computing System. Paul and I was in a subgroup that was sort of the advanced projects and stuff like this Pascal compiler. And the leader of that group got a letter. There's a guy named Jack Grimes, and he got a letter. The full letter is on my website, and it's signed by Dale Goldberg and Bill Sutherland. And it basically says, we have this thing called Smalltalk, and we'd like you to try to do something with it. And if you take it and we're writing these books, if you review the books and give us feedback and then try to implement this, we'll give you the software so you can go build products out of it. Okay? And, well, it turns out that at that time in the industry, there were rumors about this thing called Smalltalk. There were general rumors about all the things that were going on at Xerox PARC, but there's actually very little visibility in the outside world. There was a paper by Dan Ingalls in Hubble 76, I think, or 77, that describes Smalltalk 76, and there are some reports, but it was a big mystery, okay? That's right. And I remember I saw a presentation by Alan Kay at the second West Coast Computer Fair, I think in 77. Yeah. Rebecca and I was there at the banquet speech where Alan's talk was don't settle for less, I think, something like that, don't settle for anything less, where he basically talked about the vision of personal computing and showed this incredible videotape, which the thing I remember most is the Cookie Monster. But it was like, it was just if you remember, we're back in this world where we had these things with these pale green screens that would, you know, had some fuzzy text and a few lines, and after you looked at it for a while, you'd push a button and there'd be a big flash and it would disappear and you'd have a blank screen again that would start doing stuff. If you think of that's what you're used to as a state-of-the-art computer interface, and then this stuff that we're in the park, it was like totally mysterious and weird, and we wanted to do it. And so this offer came in, and of course, everybody said, yes, 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 you got to do this, you got to do this, you got to do this. On the website, you'll see there's a bunch of memos, internal memos that were written trying to justify doing this, and budgets, and what we're going to get out of this, and why in the world is Xerox doing this? What's behind this? But anyway, that's what happened, and so that's the week. So we got started. The first part of the job was to review the book, and so this memo here is the meeting announcement for the first meeting. The reviewers to review the first chapter or two we got of this book, and said what we got were printed, Xeroxed copies, laser printed, of these chapters mailed to us, and we'd actually think we may have gotten multiple copies, you know, some sent in each mailing, so we didn't have to make copies ourselves. I'm not sure of that. And so the reviewers would go off and read these things, and then we'd get together in a room and try to puzzle out what it all meant. And while it was going, we ran a tape recorder. And then we sent the tapes back to Adele and Dave, and I guess they would try to puzzle out what it was we were saying on those tapes. But this is, I mean, you probably can't imagine what it was like to try to digest that material, because it's a whole new set of concepts, a whole new jargon that was being introduced. And it was in a way, and it was being presented in a way as, oh yeah, this is just natural, this is just what it is. And so we'd sit there and say, what does this mean? What's the implications of this? What would you do with this? So, and so that went on for about 6 months doing that stuff. And so we have a there was a big, huge stack of tapes generated and stuff. A few specific items of feedback I can remember from that time. There was a chapter that was on how to implement lists in Smalltalk. I think Peter Deutsch probably did. And we kind of looked at that and said, you know, it's confusing enough here to have one exotic language you're trying to understand, and then in the middle of it, now we insert this other exotic language and try to combine the two. Another point of feedback I remember, which, for better or worse now, thinking about it, but I remember the original spec for if true, if false for Smalltalk 80 was list-like in that I think anything that was non-nil was considered true. And we just finished building the Pascal compiler, and we said, now, if statements need, I mean, it needs to be a Boolean. It's either true or false, and if it's not either of those, it should be an error or something. And I guess that's how it ended up. So, at any rate, so the first phase was the book review. And that started off a whole phase of internal evangelism at the same time, because I mean, we were puzzling this stuff out, but if you can imagine the whole rest of this giant organization that was building these green screen computers, trying to get them to understand what we were doing and motivate them to think ahead to the future and stuff. And so, I mean, large parts of the next 7, 8 years of my life was spent trying to explain things like, everything is an object? What's that mean? But also things like just these concepts of what a bitmap display and how it is that the system built with this language is able to do these things that look so much like what happens on the printed page as opposed to what was happening in normal computer graphics at that point in time. And particularly to a company whose business was in building computer graphics. So I have piles and piles of presentations, a lot of which I digitized or kind of explaining these concepts. Oh, and by the way, for those who weren't born then, the reason some of these things up here are kind of sloppery and there's this kind of strange background colors, those are transparencies. And that's how you did presentations back then. You had a sheet of clear plastic and you wrote stuff on it, you had an overhead projector and you flopped things down on it and stuff. And so these are all scans of transparencies I have. That was the PowerPoint of 1980. Okay, so the next phase of the project, the deal that was proposed by Xerox was that we would go and we'd implement a virtual machine. And I'm pretty sure the original concept from Adele and her crew was that this software was being given to computer companies, and so we would go build a special computer that could run Smalltalk. And since at part, the only machines that ran Smalltalk were custom microcoded high-performance machines, the assumption was that probably that's what you need to do to run Smalltalk, and that's obviously what we do. So it turned out what we did, and it turned out like everybody else who was involved did something similar. We said, oh no, we'll take some computer we have and see what we can run on it. Right? The middle slide here, I don't know if you can read that, but it says, use a standard microprocessor, Motorola 68000, implement the interpreter and use high-level language, GCS Pascal, Pascal compiler we just build whatever minimum hardware we need to use a bitmap display, a 512 by 512 bitmap display. We went off and started doing that. And actually, really, the first versions of the interpreter we wrote in Pascal running on a DEC 10, and because we didn't have our 68000 computer put together yet, and so a few months later we had a computer, and so then we started using our Pascal compiler, which ran on a DEC 10, by the way. It cross-compiled to these microprocessors, and started bringing it up on that hardware and stuff. Just to mention some of the people who were involved with that. So with myself and Paul McCullough, Jason Penny, who was later at Gemstone, Serial Logic, Alan Otis, who those of you who know about Gemstone probably know Alan. He was the hardware engineer who built the display. Larry Katz was sort of initial project leader. Alan Purdy, who's another person who's been around the Smalltalk industry a long time, was the chair of the first OOPSA, was also on that team. So it took us, these are various schedules I found that, where we were and sort of the time frame. It took about 6 months to get a complete system up and running, where we actually had a display and could see stuff, a real bitmap display and see stuff show up on it. But about the middle of it, so what this is, so before Alan had built the display for us, we hooked a tech terminal to an RS-232 port, and this terminal is 4025. It's called. It was Tech's first raster graphics terminal, and it basically did character cell graphics, but it was which is a common way to do graphics back then, but its innovation was that the character cell map was programmable. So so you actually could do real graphics, and the terminal would dynamically take basically the draw commands and stuff, and would figure out what character cells it needed to capture, you know, probably 16 by 6 cells and which bits to fill in. And so the terminal just thought it was displaying characters, but by putting the right bits in those characters, it could create any graphics. And so that was how we first displayed Smalltalk images as it came up. And what this is showing here is actually the welcome screen, what you get when you booted up the first virtual image distribution from Xerox. And the reason it's colored here is because this is thermal paper. That's how the screen was hard copied back then, and it's aged over time. And it took significantly over an hour. I think it was closer to 2 hours to actually generate this initial display. Wow. Okay. We didn't do it too many times. And one of the things we discovered, it's kind of chopped off here at the bottom. One of the reasons it's chopped off was that we exhausted the dynamic character cell memory. So particularly with all these half-coding bit patterns and stuff. And so actually one of the things we discovered pretty quickly is if we disabled the mask function of bitblit, so we didn't get any of the half-coding, it actually we could actually display a whole lot faster, and we could actually get more up on the screen, and so that's what we did. But this is really the first output, Tektronix Smalltalk in July 1981. So performance sucked. So as I mentioned, we went and built 68,000. Other companies involved, you probably read about this in Green Book. HP used a VAX, pretty strange, but that's what they did. DECA had both a VAX project and a PDP-11 based project. There's some work going on at UC Berkeley, but you know, the general idea at the time that sort of the minimal acceptable performance was what you got on a Xerox Dolphin, and that wasn't, I think, at Xerox actually wasn't considered very good at that time. And you know, this is Tech Smalltalk down there, and not that anybody, you know, not that anybody else is very good either. And really, there was just, you know, general conclusion, and I think if you read some of the articles in the Green Book, there's sort of a bit of doom tone in there that it just didn't work. You know, you just couldn't do it on a regular machine, and it was cool stuff. But so at Tektronix, now I haven't talked here about all the internal politics and how we're shifting groups in the middle of all this, and different divisions are fighting over various sorts of computing-related technology, and we're being pulled left and right, and what have you. But this is the plan for that original team that did that original implementation of what we're going to do next, and it was largely, well, let's see if we can speed up the interpreter, and you know, maybe a faster 68,000 would help. You know, there really wasn't a lot of insight there at that point in terms of how to make this really any faster. And in fact, most of that team was actually busy looking for their next job, because it was pretty clear that effort was petering out, that it really hadn't demonstrated much. So meanwhile, Tech Labs was the Tektronix Central Research Group, and it was rapidly growing during that period. And one of the guys that they hired was a hardware engineer named Roger Bates, who had worked at Xerox PARC and had been involved in the early development of several of the Quark computers and stuff. And he came to Tech Labs and said, look, if we're going to have here a real computer research lab, we have to have some common hardware that people can do innovative stuff on. And he made a proposal for doing that, which is a machine called the Magnolia. And it was a multiprocessor 68,000 machine. This proposal here is dated, it's 1980, basically. It was early 79 to 1980. So this is really about the same time we were starting to do Smalltalk. They were starting to build this machine. And they built it. And it was a very nice machine, but there wasn't, well, Unix was being ported to it, but, you know, just having a personal computer that runs Unix like it's on a terminal is not all that exciting and stuff. So basically, I escaped to Tech Labs to put Smalltalk on the Magnolia. And this is a transfer memo, and if you read this on the website, you get a flavor of some of the politics that was going on about, oh, okay, I guess we'll let Alan go over there to work on this. We don't really care about the stuff anyway, but we have to act like it's, so it was kind of an interesting time. But I transferred to Tech Labs. Over the next 6 months, the rest of the core of that original team escaped to Surreal Logic. And if you guys haven't heard of Surreal Logic, you'll know that they were later renamed to Gemstone. Okay, and so that's kind of the direct link from Tektronix to Gemstone of the Smalltalk virus there. So what I was doing, I had spent my time there working with that first implementation and analyzing it and thinking about it and saying, it just can't be this slow. You know, it's got to be a way to make this stuff faster. And so we started doing a lot of analysis of where things were spending its time, finding things like in the Pascal-based implementation, 20% of the time was spent on dispatch, just bytecode dispatch. 40 to 60% of the time was spent on storage management, particularly reference counting, overall. We did over there on the right, there's some analysis that was showing that for a basic store operation into an instance variable, like reference counting was adding like 200% overhead to the basic operation. So we started thinking about how can we rethink how you do an interpreter in a way that doesn't have this overhead and such. And so basically I built a new virtual machine from scratch in assembly language, kind of threw away the Blue Book as a design, instead simply said, well, what do these bytecodes mean and what's the most efficient way to implement them? We did deferred reference counting as a way to reduce reference counting overhead and all sorts of things. And it worked, basically. So, oh, yes, if you build it right on a reasonable machine, you can run Smalltalk at a reasonable speed. So in about 6 months, we were, approaching Dolphin speed. In another 6 months or so, we were above Dolphin speed. We're still nowhere near Dorado speed, but because that's true scale over there. But it was as usable as a Dolphin, okay? And people had done real stuff with that. Now, one of the things that happened there, around that time, I remember wandering into the lab, Guy wandered in and said, hey, what are you doing here? What is this thing? How does it work? So that was Ward Cunningham. And Ward Cunningham really picked up like immediately on this stuff and said, I want to do stuff with it. And he started taking that Magnolia implementation, before it was even finished, it started actually trying to do real CS with it, or real I don't know if Ward ever actually does real CS, but it's a real exploratory development, experimenting, tweaking, doing incredible demos. So he really was the first Smalltalk user and really was just key to evangelizing Smalltalk, certainly inside Tektronix during that period and then to the rest of the world after. So, unfortunately, I haven't been able to find, this is the best picture I could find, and it only shows a Magnolia display. It doesn't show the actual compute box. But for that, everybody in our lab was getting these machines, and their choice was either to do stuff with Smalltalk or do it in a Unix command line. And so Smalltalk rapidly became the primary environment for this 50-person computer science research lab, working in all sorts of different directions. Silicon compilers, algorithm, animation, instrumentation type stuff, just all sorts of stuff, all being done in Smalltalk. And so like a lot of corporate research labs, there's an annual science fair where you kind of show off what you've done to the executives and the rest of the company. And so in late 1982, at the science fair, we demonstrated Magnolia running Smalltalk, doing lots of interesting things, many of which were created by Ward. And the execs would come through and they'd say, we really need to do something with this. Scratch their heads and then wander off and stuff. So subsequently, so that was in like November or December, 82. So in early 83, I and a guy named Tom Merrill, who had been sort of the technical lead of the whole Magnolia effort, drafted a couple of proposals here about, well, what should Tektronix do with Smalltalk? There's a lot of discussion of why it's an interesting technology and all that stuff. But the key thing ultimately was that, well, look, we could build a machine, an inexpensive machine for about $10,000 that had the performance of a Magnolia and got Smalltalk to the world, and that could be a tech product. Now, so at the same time, in the actual graphics product unit that built terminals, there's a project called Unicorn, which was Tech's first attempt to build reasonable raster graphics terminals that were at a reasonable price point. And Rebecca happened to be the software project leader of that project. And there was a lot of innovations of this. Just being color raster graphics is an innovation for Tektronix. It wasn't a green storage tube flash. But things like, they weren't metal. The cases were made out of structural foam and had some design to them, and were designed to be cost effective to engineering stuff. And so that's what Unicorn was. And so fundamentally, the proposal we came up with was, well, let's leverage as much as we could from the Unicorn project to create the Smalltalk machine. And the manufacturing technologies, the actual physical case, just all sorts of stuff, and create basically created a jointly staffed project between Tech Labs and IDG, which was the product group, to create this machine. And that project was called Pegasus. And this is, tonight you're going to see a video of this machine running, but this is sort of the guts of a Pegasus prototype. It's basically the top thing that looks like the display is the display, but it's also the CPU, and it's really had two boards. Over in this side, this is the actual processor board and a megabyte of memory, and in back there's an I/O board, and then there's an auxiliary board. This particular box had 2 megabytes of memory in it. The standard configuration was 1. But that's sort of what a Pegasus looks like. Now, the product unit that did this became known as AI machines. And so there's a story about how did Smalltalk become an AI language. So Mike Taylor, who's floating around back there somewhere, was appointed as the marketing manager of this new team that was building this AI machine, this Smalltalk machine, Pegasus. He was basically the marketing management for the Pegasus project. And so this is a little conversation Mike and I had, as best as I can reconstruct it, from the summer of 1983, which was, Mike, we need to figure out whose Pegasus customers are going to be. So what's Smalltalk good for? And I go, well, it's a highly interactive, exploratory programming environment. And the marketeer says, yeah, but who needs that? And I think, oh, gee, AI is really big right now. I just saw Time Magazine. That AI and the Japanese fifth generation computer project is going to take over the world. So I go, it's an AI language. And Mike goes, really? And I go, well, sure, it has a garbage collector, and it's good for symbolic processing. It's just like Lisp. Everybody knows Lisp is an AI language. So Pegasus is an AI machine like a symbolics? That's incredible. We can really do something with that. Wow, this is great. So about a week later, Mike came back and said, I did some research, and people say they also want, they really want Lisp and Prolog. And I kind of go, well, okay, I guess we can do that too. So, about a year later, in 1984, in August, at the AAAI conference, Tektronix introduced the 4404 AI development system. Came with Smalltalk as its primary language. Optionally, you could get Common Lisp and Prolog, but it was the first. Certainly, it's the first commercial Smalltalk machine that was mass-produced and was at a price point that organizations could afford it. Xerox XSIS had shipped Dolphins and maybe a couple of Dorados and stuff, much higher price points, but those were much more focused, kind of custom products. This was just a general catalog product of Tektronix. We did have Common Lisp, which is another whole story. We took it back to Japan. The main reason having this up, a couple of reasons in this case. One of which, on the screen here, you see all this electronic circuitry and stuff. So this was an AI machine. There's a lot of effort at the time to do AI type things in Smalltalk. And so this was sort of an expert systems prototype that was done in tech labs that was for troubleshooting electronic circuitry and stuff. And so that's what the background image is here. But the other main reason, I just wanted to give you another picture there of young Alan. And there to my left, that's Dave Squire, who is the general manager of the AI Machines business unit. So a year later, we introduced the Tech 4406, which was a 68020 based machine with a much larger screen, and we developed a whole new Smalltalk for it, which we called, well, basically it was 32-bit object pointers. The previous Smalltalk that was only 16 bits. You could only have 32,000 objects. You can now have an arbitrary number of objects. There's no object table, big, small integers. I think it's the first commercial product that actually, using a standard microprocessor, that actually had a generational garbage collector. Symbolics did, but they were far from being a standard processor. And its performance approached that of Dorado. So we really, we've really gotten up to that level of making Smalltalk a real environment, a real language. The next major innovation at Tektronix was, I think it was shipped in 1988, was color Smalltalk. And Tektronix, since it was a color graphics person, just really deeply looked at what it takes to take the Smalltalk style of bitmap graphics, bitlet base, and turn that into a true color environment. And Rebecca was project leader of the color Smalltalk project. And, you know, again, a typical, just incredible Tektronix over-engineering, you know. It supported, you know, 4 different color models, right? Yeah. So, you know, you could pick what color model you wanted to use. It would automatically translate forms using one color model to the other color model. We figured out, you know, extensions to bitlit that said, well, what's the equivalent when you're working with pixels for doing all these Boolean combinations that were going on, and then we had a custom chip to actually do those combinations and stuff. It actually shipped in a family of machines that were called the 4300 series. Now the reason the name changed is because by the time 1988 came around, the AI bubble had kind of burst. And we're back to being more just workstations. And it's also true that by 1988, that the time when you could build a computer that was dedicated to a single programming language was rapidly passing. So, so really, this is the decline, really the decline of Smalltalk and Tektronix. As a business, it had reached its high point. The company is going through lots of other issues, and so really this series, color Smalltalk, is really, I guess, the pinnacle of Smalltalk and Tektronix. I just want to quickly say, lots of things were done in the application area at Tektronix and exploring various ways to apply Smalltalk. Obviously, people doing stuff that looks like oscilloscopes and stuff with waveforms. But over there on the far side, Tektronix had a whole business, IC tester business, and they developed an interface to those IC testers that were programmable using Smalltalk. Probably the most elaborate thing, and you should talk to Dale sometime. I don't think we're going to have time this morning. I was going to have him come up here. But basically, at Tektronix, Dale and his team developed a thing called ADS, which was a CAD system for building analog ICs. Tektronix is really big into analog, obviously. And it was, you know, as Dale describes it there, but it was 2,100 classes, is that what you said? Yeah, so at the time it was this huge application which was actually used at Tektronix for at least 15 years to design their analog ICs. And probably just that effort by itself justified everything Tektronix ever spent on Smalltalk. Another thing, well, Tektronix was an oscilloscope company. And the whole generation of oscilloscopes that we designed in the late 80s were driven by Smalltalk. And up here, this is something I found. This is actually the boot sequence pumped out an internal serial port on one of these scopes. That's probably not readable, but right there it says starting Smalltalk. So that when you're running any of these scopes, you're running Smalltalk. So just finally, kind of wrapping up here, a couple things. So obviously Tektronix built a whole business about this. There's tons of people who got their start with Smalltalk at Tektronix or using Tektronix Smalltalk. But just, you know, really some of the people, some of the major impacts in the industry that came from people at Tektronix who were involved with Tektronix Smalltalk. I just tried to, you know, put up here people like Ward and Rebecca and Kent Beck And John Wigan, who's one of the architects of Eclipse, some of just the major things that came out of that. You know, Ward's concept of the wiki, extreme programming, pair programming was the way Ward and Kent used to work on their Magnolia as they experiment with Smalltalk applications. So really, Tektronix Smalltalk and the Tektronix Smalltalk effort, I think, had an impact that went far beyond the degree to which what Tech did with Smalltalk is actually known today. Finally, I'll show this slide again tonight. This is kind of the flows, some of the flows of some of the people here who, you know, to and from Tektronix, including obscurities that Glenn Krasner went from Tektronix to Xerox. Glenn was actually an intern at Tech. But you can see there's, you know, major influence on Gemstone. A whole set of people who, in North Carolina, with Knowledge Systems and IBM, people like Sam Adams, who's now a distinguished engineer at IBM. Tektronix works closely with OTI. OTI was heavily involved in the development of the scopes, and Tektronix provided much of the early, that project was early funding for the development of Envy. The whole series of instantiations companies. So fundamentally, that when the Tektronix effort ended, I and Mike and Paul founded a company called Instantiations, which eventually merged with Digitalk, which merged with Park Place Digitalk, and then reinstantiated a couple times as appropriate. And even today, a couple of the tech Smalltalkers are at Google working on tools for Dart, which is itself kind of a Smalltalk derived language. So again, it's kind of the map of the impact of people impact of Tektronix Smalltalk. So that's it, basically. Time's up. And check out the website. It really, there's lots of good stuff there.
Thank you very much. And so you made the perfect introduction to our next speaker,
Okay.
who will now